gathered here to do a design thinking activity on deep neural networks. We are going to present it as a role play on deep neural networks. As you all know, deep neural networks are just the backbone of your machine learning or your deep learning algorithm. So it has input layer followed by multiple hidden layers and output layer. Now let's discuss it as the role play.
Good afternoon all, myself Kavipriya from the Department of Artificial Intelligence and Data Science. Now we are going to perform a role play on the topic of deep neural networks. Deep neural networks is also known as deep networks, which is a subset of artificial intelligence. In this role play, we have to discuss about how deep networks are used, what are their applications and what are the challenges. This role play will be enacted by myself as a host anchor, Aditya as basics explainer, Bharanidharan as technical explainer, Balaji Ayanar as applications explainer, Mahalakshmi as explaining challenges.
So before getting deeper inside the topic, first let me ask you, what do you mean by neural network?
Now I am going to explain about neural network. Neural network is a model inspired by the human brain. It consists of neurons connected together to process information and make decisions.
Good explanation, Aditya. Now one of you tell me what makes a network deep.
When a neural network has multiple hidden layers between input and output layers, it is a deep network. These multiple layers helps model to learn complex patterns from data.
So you mean to say that neural networks helps to make the complex problem into a simpler one.
To explain the architecture of the deep network has 3 layers. The input layer, this is the input layer. Input layer means this is the raw data like messages or text, and the next one is a hidden layer. Hidden layer means this is the multiple layer where learning happens, and the last one is the output layer. Output layer means it gives the final prediction of the result, and each neurons explains the weighted sum of inputs, and it applies the activation functions like ReLU.
So Bharani, then you told the activation function, no? So what do you mean by activation function?
Yes ma'am, activation function means non-linearity, because without them we cannot learn complex data patterns such as face recognition, image recognition.
Ma'am, can you explain how deep networks learn?
Yes, Kavipriya. Deep networks learn through a process called training. Now, this will be explained further by Bharani.
Yes, ma'am. The training happens using forward propagation, backward propagation, loss function, and gradient descent. The forward propagation means the data moves from input to output, and the loss function measures the error. Back propagation sends the error backward. It will perform many epochs until the network performs well.
Exactly, Bharani. This is how the deep neural networks work and to improve its efficiency.
Now let me explain the application of deep networks. Deep networks are usually in image recognition, face unlock, speech recognition, voice assistants like Siri and Alexa, autonomous vehicles, car self-driving, healthcare, disease prediction and diagnosis. Deep networks are used to machine can hear, understand like humans.
Balaji, can you give some real-time examples of deep neural networks?
Yes, ma'am. In hospitals, deep neural networks are used to detect cancer previously from the early stage by using MRI scan and X-ray, more accurate than traditional method.
So I hope you are all clear about what is deep neural networks. Now one of you tell me what are the advantages, its challenges and the future scope.
I don't know, I'm Mahalakshmi. I would like to say about the challenges and even the advantages of deep neural networks. In deep neural network, there are more advantages, but I would like to list out only the major 3 ones. One is it is highly accurate, and the next one is it is automatic extraction of features, and the third one is it can resolve large and complex data sets. Even in deep neural network, there are limitations, such as it requires large data sets, and it also have high computational costs, and it takes time to interrupt those data sets. So the black box testing will delay, but still, in future, deep learning has more efficient and energy saving, and it is shown in AI researches and like in the sectors of education, healthcare, and robotics.
Well done, Mahalakshmi. Now, Kavipriya, tell me the conclusion of this deep neural networks.
Let me conclude that deep neural networks is modern AI technology which is very useful in having multiple hidden layers to have a better accuracy. In this role play, we have seen that deep neural networks architecture and how they have used in modern real-time applications and their challenges and limitations also. Like we seen in deep neural networks architecture, it has input layer and hidden layer and output layer. In input layer, we have seen so many inputs are given to the hidden layer. It will process and send back to the output layer. And also we have seen about the activation functions, which have a summing of weighted average and bias. Like also in applications, in many applications, real-time applications such as in healthcare, transportation and communication, like so many real-time applications were worked based on deep neural networks. Even though it has challenges such as high computational cost and data transparency, we have so many advantages in deep neural networks.
Very good, Kavipriya. Now, one of you tell me what is the key advantage of deep learning that you have understood from this role.
I would like to say one of the major advantages is that it can automatically learn from raw data.
Very good. Thank you all.